Okay, so here we have to sketch the graph of f of x is equal to negative the square root of x plus 1 plus 1. And so to do this, what we can do is compare this transformed graph of the square root function to the original square root function. And here's the general form of transformations. The a value in the front represents the vertical stretch. The b value represents the horizontal stretch. The h is the horizontal shift, and the k is the vertical shift. And so here, our a value is -1. And if we have a or b that's negative, it means it's reflection. And a, because the a value represents the vertical stretch, if a is negative, it's going to be reflection over the x-axis, meaning any y value, the vertical, like y represents the vertical, it's going to be flipped over the x-axis. And so b is 1, so we don't have to worry about that. H is -1, because x minus -1 gives me x plus 1. And so it's horizontal shift 1 unit to the left. And k on the end here is +1, and so it's a vertical shift in the positive y direction, so it's 1 unit up. And so we can compare points on the original graph of y equals square root of x. We just plug in perfect square. So 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And we compare this to the new graph where our points, our x values will be subtracted by 1 because of the shift left. It'll be -y because remember, y became -y when it reflected. And then it'll be +1 because of the 1 unit up. So we just plug these x and y coordinates into these new equations. So you can see all the new x coordinates have been subtracted by 1. And all the y coordinates have been, say this one is -2 plus 1, which gives me -1. And so I can plot these 4 points, and you're going to see this is what our graph looks like. And you can see how this is, say this dotted line here is the square root of x. This is negative the square root of x. This bottom dotted line, and then I shifted it 1 unit left and 1 unit up.